Hi, my name is dr. Ahmath. In this video lecture, we're going to discuss about the linear functions. Previously, we talked about the functions, and we can give various definitions of the functions. And one of the most intuitive definition of the functions would be to define a function as a machine which transforms an input value into the output value. So basically, the function is going to be some kind of box. And if I enter some input value x into this, it's going to transfer me to the y. And this transformation of the x into the y is actually called as the function. So this is going to be denoted as f of x. So depending on the shape of this function, x is going to be transformed into the y differently. And whenever I say differently, I would like to try to understand the dependency of the x into the y. So what does it mean? Basically, if I just change a little bit the x, how the y is going to be changed. So through this course, we are going to talk about different types of the functions. Starting from the linear functions, we're going to continue with the quadratic functions, exponential functions, trigonometric or logarithmic functions. And all of these functions are different in terms of this dependency of the x and y. So if you change the x, how the y is going to change. And whenever we say that the function is linear, we basically say that this dependency of the x and y is linear. Basically, if you change the x, then the y is also going to be changed, but by the factor of some scalar number, by the factor of some constant. So what do I mean? So let's do a couple of examples and try to understand what does it mean. So the first example. So let's say a hotel charges $20 per night. Okay, so if you would like to stay, if you would like to stay 3 nights, how much you need to pay? How much you need to pay? Well, it's really easy to calculate, right? So we are just going to multiply the 3 into the 20. It's going to be simply $60. So now what I would like to try to do is I would like to change this input. So in our case, x is going to be, so basically the number of the nights or number of the days which I would like to stay in this hotel is going to be my input. And the output is going to be, so the amount, how much I need to pay for this. So this is going to be the output. So this is the output. So what I would like to try to understand is, if I just change the input, how the output is going to change. So in order to do this, let's create a table and try to understand this. So this is going to be x, the number of the nights which I would like to stay in the hotel, and the y is going to be the price which I need to pay. So if I would stay 1 night, I would pay $20. If I would stay 2 nights, I would pay $40. 3 nights, $60. Like 4 nights, $80. 5 nights, like $100, and so on. So you see that the difference, so if I change the x by 1, then the y is changing by 20. But if I change the x by 2, then y is also going to change, but it's going to change by 40, right? So you see, so these changes are proportional. So if I change basically the x's a little bit, then the y is also going to change by some factors. So in this case, by the factor of 20. And if I change the x a little bit more, then the y is also going to change a little bit more. So the changes are proportional. And here in this case, the changes on the x is going to change the output by the factor of 20. So where 20 is a constant. So if I would like to create the relationship between how much I need to pay and the number of the nights which I would like to stay in a hotel, the relationship would be y is equal to the 20x, isn't it? So it's like basically I can get every value here on the y row by just substituting the values of the x row into this rule or into this equation. So this is a linear function. Linear function. So let's make our example a little more difficult, since this is not a general form of a linear function. So let's make another example. So let's say you would like to park a car into the parking slot. So, and you are going to be charged like $2 per hour for the slot. So you pay $2 per hour for parking your car. So additionally, you need to pay a service fee. Additionally, you pay like 0.50 cents a service fee, which basically doesn't depend on how many hours you would like to stay, for how many hours you would like to park your car, right? Okay, so now I would like to make again a table where x here is going to be the number of the hours I would like to stay, and y is going to be how much I need to pay actually. So if I would like to stay just 1 hour, it would be just $2 I have to pay, right? Plus the service fee, which is going to be 2.5. So if I would like to stay 2 hours, it's going to be like a $4 plus the service fee, which is like a 4.5. And if I would like to stay like a 3 hours, it's going to be like I am going to pay like a $6 plus 0.5, 6.5. 4, it's going to be 8.5, and so on. So this is again a linear function. So what do I mean by the linear is that like x and y are dependent linearly. So the y, so the number of how much I need to pay, is changing by a scalar, by a scale of a constant, right? So basically, if you just change the x from 2 to the 3, so from 2 to the 3, then the y is going to change by 2, right? But here, if you just change the x from 3 to the 4, y is changing by 2. If you're changing your x from 2 to the 4, then your y is going to change by 4. You see, so it's like everything is like proportional. So that is why it's called linear. So later on, we're going to see another type of the function, and I hope that you will understand what is like, and you're going to feel the difference between the linear functions and, for example, the quadratic function. So if I would like to create a rule for this parking machine, how I would create this? So basically, y, the amount which I have to pay, is going to be 2 times the number of the hours I would like to park into there, plus the service fee, 0.5. So this is going to be the equation or the rule for this parking machine. So you see, so previously we've seen this equation in this form, y is equal to the 20x. And here we've got like another function, y is equal to the tx plus 0.5. So in general, a linear function is defined as y is equal to the kx plus b. So where k and b are just the real numbers. So they can be any two real numbers. So this is the general form of a linear function. What basically tells you that if you change the x, then y is going to be changed by this scalar, okay, linearly. Good. So here, K is called, so there are also the definitions of this K and B. So the K is called as the slope, and B is called like a y-intercept. Y-intercept. So it is about the graph of the linear function. So what I would like to try to do now is to draw the linear function. Okay. So you may guess that any linear function is a line. So any linear function is a line. If you would have a coordinate system, the rectangular coordinate system, so I would guess that you may draw different types of the line, right? So for example, you may draw this kind of line, or this kind of line, or this kind of line, or even like this kind of line. So all of these lines are in some sense linear functions. What is different between these four graphs or four lines? So the parameters K and B make these lines different, or their shapes are going to be different depending on the values of this K and B. So I would like to look a little bit deeper into this topic. So basically, I would like to try to understand how the K and B are changing the shape of the line exactly. So in order to do this, I'm going to do the two scenarios. The first scenario is going to be like, I'm going to fix the B. So B is going to be some value, and I'm going to change the values of the K and try to understand how the shape of the line is changing. Okay. So let's try to understand. Let's try to understand the K. Okay. So the K is basically called as a slope. So now we are going to try to understand why it is called as a slope. So I'm going to try draw a rectangular coordinate system again. So here I'm going to fix first of all the value of the B. So what do I mean by fixing is basically I'm going to choose the value of the B to be equal to the 0, always. Okay. So the first line which I would like to draw is simply y is equal to the x. So this line, y is equal to the x line. So you see here that the b is equal to the 0, and the k is equal to 1. So if I would draw another line, for example, y is equal to the 2x, then the shape of the line would be like this. So this is the y is equal to the 2x. Y is equal to the 2x. Okay? So if I would draw a third line, let's say y is equal to the 1 over 2x, then its shape would be something like this. So it is the y is equal to the 1 over 2x. So again, if I would write down the values of the slopes, here it's going to be 1 over 2, and here it's going to be 2. So you see what is changing if I change the value of the k. So basically, the slope of the line is changing, right? So basically, you're rotating. So you need to always orientate by this line. So y is equal to the x line. This should be your orientation line. So you need to always draw this, which is basically splitting the first quarter into the two, right? And the third quarter into the two. Then you need to see, hey, if the k, the value of the k, is bigger than 1, then your line should move towards to the y-axis, okay? So for example, you may guess that if the k is equal to the 3, for example, or 4, then that line is going to be something like this, right? For example, this might be the equation of the function of the line y is equal to the 4x, okay? So if you are increasing the value of the k more than 1, then you're basically going towards to the y-axis. And if you're decreasing the value of the x, value of the k, sorry, then you are moving towards the x-axis. Again, increasing the k moves your line or rotates your line towards the y-axis. Increasing or decreasing the k rotates your line towards the x-axis. Okay, for example, here it's 1/2, which is smaller than 1. So this is basically how your line is going to change. Okay, so one more thing which is really important is that it's really important for us to know whether it is possible to take the negative values for the k. So it appears yes, we can assign the negative values of for the k, not for the x, for the k, and they are going to look like this. For example, this line, which basically splits the second and the fourth quarters into the two, has the following equation: y is equal to the minus x, where the k is equal to the minus 1, right? So again, if you remember, the general form of the linear equation is kx plus b. And if the b is equal to the 0 and k is equal to the minus 1, then your equation is going to be y is equal to the minus x, right? So this is going to be minus x. So if you are basically moving towards to the y-axis, rotating this line towards to the y-axis, then the absolute value of the slope of the k is increasing, okay? So for example, this line, which basically splits everything by 2 here, is going to have the equation y is equal to the minus 2x. You see, so in its absolute value, so k is equal to the minus 2. So in its absolute value, it is bigger than minus 1, right? So it's basically you're rotating your line again towards the y-axis. And if you are decreasing the value of the k and its absolute value, you are going to move towards to the x-axis. So for example, so this line, which is going to be here, has the equation y is equal to the minus 1/2x. So one of the easy rules which I usually make and teach to the students is to understand what is the sign of the slope, whether it is positive or negative, is to use your hands. So if you're able to put your left hand on top of the line, it means that the slope is positive. And if you are able to put your right hand on the top of the line, it means that the slope is negative. Okay, your left hand slope is positive, your right hand, the slope is negative. So I'm going to use an application which is called the GeoGebra in order to try to understand how the k and b are changing. So here I would like to enter, first of all, the values. So let's say k is going to be equal to, so k is equal to 1, let's say. So, and also I need to define the b. b is equal to 1, or let's make it 0. Then I need to make a line. Y is equal to, y is equal to k times x plus the b. Okay, so it is going to be this line. So actually, if the k is equal to the 1 and b is equal to the 0, you can see here that this is going to be this line where you can put your left hand, and it's basically splitting the x and y axis exactly to the 2. So now, if they decide to increase the value of the k, then this line should rotate or should move towards to the y-axis, should rotate towards the y-axis, right? So let me just increase this. For example, I'm going to increase the value of the k. So you see, so if I'm increasing the value of the k, so now it's like 3.56, 3.4, and so on. So if I'm increasing, it's rotating towards the y-axis. And if I just decrease this, if it is less than 1, okay, it goes towards the x-axis. So if I just make it negative, then again, it's going to be this kind of line where you can put your right hand on the top of this line. And again, if you increase its absolute value, it goes towards it rotates towards the y-axis. And if you decrease its absolute value, it rotates towards the x-axis. So this is how the k changing your line. So k basically defines its slope, right? Okay, so the greater the value of the k, it means that it's more vertical. Whenever k is equal to the 0, it's basically the horizontal line. Okay, k is equal to the 0 means horizontal line. So probably this should help you to try to understand how the k actually stacks to your line. So just remember that a k is equal to the 0 is a horizontal line. Okay, so now if I would like to try to understand how the b is changing, so I'm going to use again the GeoGebra. So here it is. So I'm going to now fix the value of the k. So let's make it 1 always. Okay, so now I'm going to change the value of the b. So that whenever b is equal to the 0, it means that, or let's make a k to be equal to the 2. Okay, so if I change the value of the b, so it is going to just change the height of your curve, of your line. So it basically tells you that at which point on the y-axis your line is crossing with the y. So if your line is not vertical, it has an angle, but it is not vertical, then it's definitely going to cross with the y-axis at some point. And this b is the point where exactly it's crossing with the y-axis. So if the value of the b is equal to the 2, it means that your line is going to cross with the y-axis at the 2. If the value of the b is, for example, -2, it means that your line is going to cross with the y-axis at the -2. So this is what does it change the b. So k defines the rotation or the slope of your line, and b basically defines the height of your line. Okay, so what I'm going to do now is, so we need to learn how to draw a line and how to get an equation of the line. Okay, so basically if the graph and the equation. So if you are given the equation, how to draw this, okay? And at the same time, if you are given a graph, how to derive the equation. So the two questions are really important. So we are going to start from the first one. If you're given an equation, how to draw a graph. For example, if you're given the equation y is equal to the kx plus b, what you need to do is, so algorithmically, so the step one, so assign different values of the x for the x and find the values for the y. Assign any two values for x. So basically, they are going to be x1 and x2. You can choose them as anything. For example, 0 and -1, or -1 and -2, it doesn't matter. Step number 2, basically substitute x1 and x2 into the equation and find y1 and y2. So find y1 and y2. So there are the pairs, right? x1 and y1 is the one point, and x2 and y2 is another point. So they are on the line, definitely, okay? So they draw 2 points. So step number 3, draw these 2 points, basically x1 and y1, and x2 and y2, and just connect them. So step number 4, connect these 2 points. Connect. So let's make an equation, right? Let's make an example. So you're given an equation, y is equal to the 2x minus 3, for example, okay? So in the step number 1, what we need to do is we need to assign any values for the x. So step number 1, so I'm going to choose x to be equal to the 0, for example, and xt is going to be equal, let's say, to 3 over 2. Okay, and the step number 2, what we need to do is we need to find a y1 and y2. So y1 is going to be 2x1 minus 3. If you substitute x1, which is 0, it's going to be simply minus 3. And y2 is going to be 2x2 minus 3. If you substitute 3 over 2, it's going to be 3 minus 3, which is 0. So I've got the 2 points. So step number 3, I've got 2 points. x1 and y1 is going to be 0 and minus 3. And x2 and y2 is going to be 3 over 2 and 0. And what I'm going to do is I'm going to basically put these 2 points on the coordinate system and just connect them. Okay, so this is the last step, which is like more or less straightforward one. So y and x. So I'm going to draw the first point, which is going to be 0 and minus 3. So this point is 0 and minus 3. And the second point is 3 over 2, which is 1.5, right? So 3 over 2 and the 0. So what I need to do is I just need to connect these 2 points. Okay, something like this. And this is going to be the graph of the equation. Y is equal to 2x minus 3. Okay, so you see here that this line is crossing with the y-axis at the minus 3, and the slope is a little bit goes towards the y-axis, right? Since the slope is equal to the 2. So now the second problem is a little bit more difficult. So if you are given a graph, how to find the equation? So let's say given 2 points on the line. So they are P1, let's say, with the coordinates x1 and y1, and P2 with the coordinates x2 and y2. So how to find the equation of the line? So the steps are the following. So the step number 1 is to find the slope. Find the slope of the line. So we are going to find the slope of the line using the following formula. K is equal to y2 minus y1 divided to the x2 minus x1. So unless your line is not vertical, the k is going to be some finite number. So vertical means that the x is not changing, right? So x2 minus x1 is basically going to be 0. So the k is going to be infinity. It means that your line is vertical. So in the step number 2, what we need to do is we need to find the y-intercept. What does it mean? So we assume let's make it k1. Okay, since we know it's valid already, that the equation of the line, is y is equal to the k1x plus b, right? Since I know what is the slope of this line already. So since the point P1 with the coordinates x1 and y1 lies on this line, then the coordinates of this point should satisfy the equation. Basically, if I just substitute the coordinates of this point into the equation, then the equation should work, right? This is what does it mean that the point is on the line. So I'm just going to substitute this. It's going to be y1 is equal to the k1 x1 plus b. So here, I just found the k1 in the previous step. y1 and x1 are given along with the point, and the only thing which I need to find is the b. So b is going to be equal to the y1 minus k1 and x1. That's it. I need to find k1, or k, the slope of the line, in the step number 1. And in step number 2, we just need to find the y-intercept. So let's do again an example. So let's say we're given 2 points, P1 with the coordinates 5 and 3, let's say, and the P2 with the coordinates 3 and 10, okay? So I need to find a line which passing through these 2 points. So the step number 1, so find the value of the k, which is going to be y2 minus y1 divided to the x2 minus x1. So y2 is 10 minus 3 divided to the x2 is 3 minus 5. So you see that the k is going to be negative. So it's going to be 7 over 2 with the negative one. Okay, so in step number 2, we know that the equation of the line is minus 7 over 2x plus the b, right? At the same time, I know that if I substitute the coordinates of one of the points into this equation, it should work since the points are on the line. So let's substitute the coordinates of the second equation. What does it mean? It's going to be 10 is equal to the minus 7 over 2 times to the 3, right? So plus the b, then I need to find the b, which is more or less straightforward, right? The b is going to be equal to the 10 plus 21 over 2, which is going to be 41 over 2, right? So it's 10 times 2, it's going to be 20 plus 21 is 41. That's it. So I found the k, the slope of the line, and I found the b, which is the y-intercept. So the equation of the line, which is passing through the 2 points P1 and P2, is equal to the minus 7 over 2x plus 41 over 2. So this is how we need to find the equation of the line. So what we've talked today. So we talk about the linear dependency of the input and output. We talk about the linear equations in general and its parameters, basically the slope and the y-intercept. We discuss how these parameters are changing the shape of the line. And also we discussed about how to draw a line if you're given an equation and how to derive the equation if you are given the drawings of this line. Okay, thank you very much.